Welcome back to cluecon Deconstructed. We've got two great speakers lined up for you, and let me let you into a little secret. If you're into open source speech technology or WebRTC, you're going to want to make sure you pay very, very close attention, because we've got some top class content delivered by project leaders for you. But we can't go there yet. We need to hear from Abby. Abby, how's everything going with you?
Everything is going amazing. cluecon Deconstructed is going so well so far, and I'm so glad we get to connect with everybody and hear from such amazing speakers. I just wanted to let you know that the next raffle prize is going to be drawn at 3 o'clock today. So make sure to keep your ears perked if you want to find out who won. Other than that, tonight at 4:30 p.m. Central until 6:30 p.m. Central, the founders of FreeSwitch are going to be hanging out right here at cluecon Deconstructed in the lounge. So if you go to the cluecon Deconstructed link, which you can find on our website, you can join us for a chat with Anthony Minasali, Brian West, and Michael Jarris. It's going to be very casual, so you're all invited, and I'm so looking forward to that. And then tomorrow at 10 a.m. Central are the dangerous demos. So even if you're not presenting, make sure to jump in the dangerous demos room to check out what everyone's been working on. And then the gigabit reception is later on that night. And that's all the announcements I have for now. I can't wait to do the raffle at 3 o'clock.
I know, it's so cool. And of course, just by watching the dangerous demos, people can be in for a chance to win that amazing laptop you showed us a little while ago. So that's very cool indeed.
We can show it again in case you guys are a little curious. This is our grand raffle prize. Ooh, it is a custom engraved MacBook Pro. This is one of a kind from the craziest year of cluecon there hopefully ever will be. So make sure that if you want to enter, all you have to do is join one of the rooms at here on SignalWire Work here at cluecon Deconstructed and hang out for a little bit, and you're automatically put onto our list and eligible to win a raffle prize. And if you sadly don't win a raffle prize, the laptop isn't up for sale, but we do have a swag shop where we have some fun games, some t-shirts, bags, hats. So if you're interested in checking that out, you can look at signalwire.community, our Slack channel, and where we will post the link to our swag shop that's going to be open for 1 whole week starting today. So that's all I have for right now. I'll see you guys in an hour.
Thank you very much, Abby. We appreciate that. I think the words cluecon and crazy tend to go together almost every year.
Oh yes.
Now, we need to get our first speaker in. So bye-bye to you, Abby, and hello to Nickolay, who's all the way from Russia. How are you doing today, Nickolay?
It's all great. Thank you, David.
It's great to have you along, and you're the leader and the main developer in the Vosk open source speech technology project, I believe. Can you tell us just a little bit about that by way of a background before we get to your presentation?
I've been in speech since 2003, and I've been working on the various parts of the technology, from TTS to speech recognition to voice identification, and many, many related projects, including NLP as well. I've been doing many projects in like recent voice assistants and things like that. So really wanted to share a kind of experience we have with the speech technology and share how it applies to the FreeSwitch platform, which I consider one of the main platforms for the open source world, as telephony and broadcast and web meetings and related things.
That's a great background. Thank you, Nickolay. A good long history, and collected the set of ASR, TTS, and SVI, as it used to be known, speaker verification and identification, the authentication side of things. Now, if you'd like to go ahead and share your screen, or we'll switch your screen share on, I should say. There we go. We're nice and up, and so we'll let you carry on with your presentation, Nickolay.
Yeah, let's go. So hello, everyone. This is our project, Alpha which is the project working on the speech technology we've been working on, like I said, we've been working on the speech technology for quite some time. And one of the big projects we've been working on and maintaining is same-use Sphinx, which is also very famous as Pocket Sphinx. Pretty, popular project in speech technology, which was used by for many years by many companies to implement speech recognition. Things changed. Yeah, things changed very quickly in our area because since 2015, neural network came in and it's totally changed the world of the speech recognition. And new toolkits appear. We worked a little bit on Caldi. We worked a little bit on Neural TTS. And since a couple of last years, we try to develop more user-friendly, more easy-to-use project called Vosk. And I will tell a little bit more about it. But first of all, let's discuss overall, status of the speech technology and related things. So since 2010, it was a big change when like I said, when neural networks were introduced, and it totally changed everything in our world. The life is not quiet anymore, and there are thousands of people who are competing, and they race for perfect AI and doing many different things in different parts. First of all, there were great progress in all the areas related to speech. For example, speech recognition improved like 4 times compared to previous technology. Now you can recognize, still not perfectly, but 80% of the call center speech can be properly recognized compared to much less numbers before. Then in the speech synthesis, we have really great progress as well. We've got improvement in the naturalness and the overall naturalness from 3 of 5 to 4.5 grade, which almost gets to the natural speech impression. Then we've got the great progress in speech compression. For example, if you know the recent codec based on the neural network called LPCnet codec, which provides great quality of the speech at just 1.6 kilobit per second bandwidth. Great progress in voice verification, voice conversion, and many, many other related areas like speech denoising, fake speech spoofing, and everything else. This great progress was, justified by a couple of important points, and one of them is a huge progress in compute. Basically, what NVIDIA has done is just amazing improvement of what you can, compute and how much matrices can you multiply in the single node, and it's getting more and more complicated because now everyone is racing for more and more powerful neural networks, bigger neural networks, and you probably heard that now you have to run the supercomputers to do this kind of research. For example, recent popular famous GPT model from Google, which can naturally have a natural chatbot, a natural dialogue. It was trained on 5 million kind of cluster for about 1 month. And if you want to reproduce this in your simple environment, in your home environment, with a simple server and with just 2 GPU cards, you will be able to do that in 30 years or so. So really enormous amount of compute enabled really great neural network technology. Unfortunately, this creates a big problem for small companies and for researchers, because unless you do not have access to this compute, you cannot really do anything with AI. You can only, run pre-trained model from the Google, and even that getting more complicated, because if before you can run these pre-trained GPT-3 on your server, on your GPU card. With the bigger models, they do not even feed the GPU card for running, not just for training, just for running. And that creates a big problem. Hopefully that will be solved by more advanced algorithms, or even, new technology like optoelectronic neural networks. But who knows? It still takes time to see that. Also, another critical thing about neural network technology is that it changes very quickly. Here, for example, we listed the methods which were used for speech synthesis, and you see it was changing every year. In 2016, there was a WaveNet speech synthesis codec, which was introduced by Google. Then they introduced WaveRNN, then NVIDIA introduced WaveGlow. In last year, Melgan was popular, and now multiband Melgan introduced. So it's kind of changing every year and very frequently updating stuff. So you cannot really catch with it unless you're really a big company and have 50 developers trying to introduce all the new stuff in the world. Yeah, so only, if you really committed to the open source, you can kind of race that fast together with the big giants. But there are good things as well. For example, one problem which was kind of solved is the data availability problem. In 2010, the big problem was that you didn't really have the data to train your system. You have to carefully collect it, and you have to pay a big amount of money just for carefully collected and processed data. But now you can just use enormous amount of annotated, dirty data. For example, you can use parallel data from the videos, and you can learn from that. Or you can use the parallel data from other languages. For example, you can use English data to train German speech recognition. Or you can use, for example, video picture to understand, is it shooting, understand, is it, some bird singing, or is it in nature? So really, these days you can operate enormous amount of data, and big companies operate 1,000,000 hours of data, and it's not a problem anymore, in particular if you have enough compute. And this also enabled the technology for many languages, and it made it more, democratic compared to what it has been before. But for the telephony, it's still kind of a domain where we have to work on it, and it's still not perfect, as you might see if you try practical speech recognition application. Even if you're working with the Google or IBM Watson or any other popular toolkit, you might see that it's still not accurate. And the big reasons of the reduced accuracy are kind of poor headsets. Usually it's a big problem in the call center, in particular in a cheap call center, where we have no soundproof protection between agents. We have the frame loss, we have the bad codecs which transmission companies use, and the quality of the speech is still very bad. We hope that sometime that will change when companies will start using higher bandwidth, more high quality speech. Because even when last year, when everyone moved to Zoom, people were amazed how good quality of audio is there. It's so, people in the telephony, they kind of get used to bad quality that 8 kilohertz audio provide them. They really need to move to the higher quality, and that will also give the better speech recognition accuracy. But still, 50% it's pretty usual for the call center, just because the quality of the audio is not that good. Even with that quality, there are many teams, many companies who are trying to reach AI, AI world, and try to introduce their toolkits and their solutions. Probably know there are two big companies in the speech, in the neural network world. It's TensorFlow by Google and PyTorch by Facebook, and many other toolkits which are trying to solve the same thing. Maybe it's a little bit optimal, in a more optimal way. And in speech, the situation is similar. We have the Kaldi toolkit, which is one of the main toolkits in speech recognition, which is kind of good. It's very powerful, but it's not really user-friendly because it was created for academics. We have similar toolkit, more modern one, ESP.NET, which you can also use for speech recognition things. And we have several toolkits by the big corporation like NVIDIA. We have the Facebook toolkit. We have the big toolkit from Mozilla, which Mozilla has a big team working on speech recognition, and many more toolkits by Google, by Chinese companies, and everything else. So the toolkits are different in the way they, the capabilities they implement. So you kind of has to be careful which one to use, but I know people are using all of them. Some people like one for the approach, architecture, programming language. Some people prefer another for the feature set or API stability or similar things. So it's not really that there is a single competitor here or even two competitors. There are dozens of products that you need to evaluate. And this is the reality of 2020. It hasn't been like that 10 years ago. But this is how it goes. For the TTS, for the high quality TTS, there are also many toolkits. And like I said, they appear and disappear, get popular, get users, and the people try them and they switch to another ones because new features appear. This year, the first one, TensorFlow TTS toolkit, get popular. It's based on TensorFlow framework, which I do not like quite for the API instability, but it implements recent algorithms, so it's something you can try. But there are others, like there is a speech in the speech TTS in the ESP.NET, there is speech in TTS in the Mozilla. And the big problem with the TTS is that there are many toolkits which implement text-to-speech, but all of them are kind of, over-promising what they can do. They provide you the high-quality samples which sound as a natural speech, but to create those samples, you really need a supercomputer that I listed before. So it's very important, to understand the speed of generation, the quality of generation, and, the speed is always traded for quality. So, the proper algorithm is kind of requires you to understand how it works. But recently, this TensorFlow TTS has multi-band Meltgan implementation, which is kind of recommended for speed, and it has a good fast speech implementation. So if you look on that, it creates okay speech even on the Android phone. And probably it will support the important multi-speaker, multi-style TTS soon, but it's all, kind of work in progress and might change soon when NVIDIA releases the new next algorithm. As far as I know, many people are also use pre-recorded samples to create, natural, emotional, and almost human-like experience for automated calls and for for customer interaction. That's also possible. Maybe this solution for now is kind of something you can consider, in particular if you can pre-record the audio. So the same situation is the NLP and dialogue management. There is a popular Rasa toolkit, which is really recommended. I really like the approach and how they work on these things. It's not really easy to integrate because it provides kind of over-engineered set of microservices you need to run together with the speech recognition and together with the telephony application. But it's really doing state-of-the-art research, and you can do nice things about Rasa. Also, if you are lazy, you can try Google Dialogflow. Facebook also have the toolkit, Amazon, and also the recent, DNN research implemented neural networks for dialogue management, which is the whole different story for user experience. Maybe this would be the way, because actually people are saying that simple grammar style parsing that we have right now and simple intent analysis we have right now, they are not that perfect compared to the neural networks that can learn from the human behavior, and they can implement more natural human interaction compared to the Rasa, for example, or Dialogflow. So, and you need to integrate this all into the free switch to make a really good voice application. And here you might meet another kind of problems of what is supported in the free speech, how this supported functionality is implemented. For now, it's not that great, because we have the Pocket Sphinx, we have eSpeak synthesis, which is really old technology. It is reliable, but the quality is below the expectation. We have the UniMRCP toolkit, which interoperates with the major cloud services, but cloud services are not always a solution. Sometimes you want to keep the discussions private, sometimes you want to keep the latency, sometimes you want to implement additional features, so you still might consider something more modern. Also, the design of the UniMRCP supposes that you use grammars for the accurate recognition, you use straightforward logic. If user said that, you go to there, you ask to press the button, to press another button, and this is not something that modern, voice interfaces, how modern voice interfaces work, because people are used to the big corporation tools, to the big corporation products like Alexa, and Alexa is not really created as a grammar analysis or straightforward, processing loop as a UniMRCP provides. So people really demand something more. One of our attempts to solve this problem is the introduction of the Vosk toolkit, which is basically the wrapper around Kaldi. Pretty lightweight, but at the same time, we try to make it as simple as possible, and we are trying to integrate it and, integrate it in the major telephony application and the major voice broadcasting into the major meeting, web meeting applications, to make it really, easy to plug it. Vosk is essentially kind of the server, speech recognition server, like you have the MRCP servers, which you can install with the simple Docker command. It requires quite some CPU and quite some memory, but you can run it locally and you can run all the processing locally with the good accuracy. So nice features listed here. It supports many languages, has many interfaces. It also runs a very lightweight processing, even on a small devices. If you have the free switch running on a Raspberry Pi, you can run Vosk there as well. The models are small. We support streaming interface, which means you decode audio as soon as it arrives, and you can provide very fast latency. It also allows quick reconfiguration of the vocabulary, so it's kind of like a grammar, but not really a grammar, but more like a free-form grammar, something like Google Hints, where you can say which words to expect, but the recognizer can expect different responses. And the nice thing that it supports the speaker identification as well. It's included, so you can identify who is talking as an addition to the recognition of the speech, and you can probably verify that this is the right person, and you can automatically, adjust the behavior based on the color. There are not so nice things in Vosk. It's still a work in progress. For example, it is very hard to add the words in the vocabulary, and one of the biggest issue right now that the people want to recognize the names. We have the pretty big vocabulary of 200,000 words, which might include everything required, but still, people want more. You want to add cities, you want to add local places, and it's not really good. We do not have keyword spotting, but it is planned. We want to support more languages, and accuracy needs love as well. For the call center, like I said, accuracy is still a problem, and we still need to work on that. But it is integrated in the free switch. We have the branch, and actually we have the pull request to the free switch core. Hopefully it will be merged soon. We have the simple client as a model on the free switch side, which connects to the Docker server over WebSocket protocol, which also provides nice features compared to the standard MRCP. For example, what you can do the load balancing with the standard AWS tools. For example, you run Vosk as a farm in AWS behind the Amazon load balancer. You can have the automatic scaling and all the Amazon nice things. And that's something you cannot really have with the UniMRCP. Yeah, I see the question that can I train the customers? Sure, you can train with the Kaldi toolkits. It's not very straightforward, but you can do that. There are documentation is available. Many pre-trained models are available, and a big community is there. That's it. So installation is really simple. You just compile these three, you add the configuration, and it supports the standard speech recognition API. So you can just use the standard, plain text speech to get the results as you did before with the UniMRCP. Yeah, I invite you to try it. Maybe, contact me if you have some problems with the compilation, and see how it works, and what is the latency and things like that. What is the accuracy and so on. Of course, this is not the final implementation, because there are so many things in the telephony, which in the open source recognition in the telephony, which require fixing. Here I try to list a few. One is the intelligent bear gain. For example, currently, it is implemented as a simple energy detector. So if you have a Koch on the background, your IVR prompt stops speaking, and you need to ask again, or you have the problem with your loop. You need to really understand if a person on the other end, if he asked something, or if he just produced some small sound which is not important. Speaker identification would be better, integrated more tightly, so you have the database of speaker, you can record them properly. Then it would be nice to have support multi-band, like I said, for the better accuracy, because really until we have the high quality speech, we will not be able to create intelligent speech interfaces. Just because the current 8 kilohertz speech with the bad quality, it is not really sufficient for proper understanding. And you probably try that and see that many times on the meetings when your opponents say something and you cannot really, you need to ask again just because you do not understand because of the bad quality. Natural synthesis still work, in particular emotional synthesis. And like I said, there are a couple of promising products, but situation will change soon. And integration with the advanced dialogue manager is still an issue. Because the most of machine learning is about the Python, and Python machine learning is really the only solution in the recent world. More simple and more straightforward Python integration into the dial plan would be the thing to solve, because without Python you cannot really apply all the advanced features we have now in the processing and in the natural dialogue. Yeah, hopefully we will work on those things, and that's about it I wanted to discuss today. I see the time is now. Please see the contacts. You can also find me in Slack in case you have issues, and yeah, please let me know if you have any questions.
Thank you, Nickolay. That was perfect timing from you, and we're very privileged to have a man of your immense experience in the world of open source speech technology. I saw the list at the beginning from Festival and Sphinx and all of that kind of stuff. A couple of questions sprang to mind, and you caught one of them that had come in live, so thank you for answering that, about training. But you mentioned that Vosk can act as a wrapper for both speech recognition and speaker identification. I just wanted to check, is that on the same utterance, or does it judge it on different utterances?
Yeah, for every utterance, you can plug in the speaker identification model, and it will return you the speaker fingerprint, the speaker vector, which you can, use to compare with the existing values. You can store it in the database, and yeah, you can run it as soon, in parallel with the user speaking.
Great. Okay, that's great stuff. Thank you. And you hinted at this in your presentation, but where do you think things are going in terms of the use of AI for sentiment analysis?
It's going good. It's, like I said, there are huge networks. There are really, really huge networks of the natural processing. And hopefully there will be either better algorithms or better devices which will enable them for ordinary people. Because now only big companies like Google can run those networks in production, because you need a lot of compute. But hopefully there will be more lightweight solutions. So you will be able to use them, even as simple applications.
Great stuff. Thank you very much. Now, while you're in the studio, I wanted to introduce you to our next speaker, the wonderful Lorenzo Miniero. Hi, Lorenzo. How are you doing?
Hi, David. Hi, Nickolay. Nice to meet you.
Hi, Lorenzo. Yeah.
It's good to see you. And I actually had a question, because you will have noticed, Lorenzo, during Nickolay's presentation, that he made reference a couple of times to the poor speech quality that people have suffered with in the world of telephony. Lorenzo is going to be talking to us about WebRTC. And of course, one of the mandated codecs is Opus, which is a lot broader in terms of its bandwidth. Has that made a difference to you in the world of speech technology, Nickolay?
Yeah, it's so much weighted, and not just Opus codec, but, I'm so tired of these SDP problems. I see so many, SIP connection issues that, I'm so hateful to that. WebRTC should solve at least, many, many years of the engineers trying to figure out why the opponent is silent and figure out the network address translations problem. That's what I'm waiting for a long, long time.
Unfortunately, we are still stuck with SDP, though. So.
Oh, that's good. Well, Nickolay, thank you very much for joining us and bringing your expertise to us, and the contribution to the Free Switch project as well, with the integration of Vosk. We really appreciate it. And we'll say bye-bye to you for now. And thank you very much. And just a quick reminder that if you have questions for Nickolay, then you can go to the Broadcast Cafe, and he'll be hanging out there, and will be available to personally answer your questions. Now, Lorenzo, you're flushed with success from your Janus workshop yesterday. How did that go for you?
No, it went very well. So a lot of people attended. So I was really surprised and excited about that. So.
Yeah, we had very good feedback about it. So thank you for that. That was kind of a general workshop, kind of getting people perhaps a little bit more familiar with the Janus project. But now you've got a very special talk for us, which I believe is about end-to-end encryption in the world of WebRTC. Something, of course, that's come into much sharper focus since we were all kind of forced, in a way, to use more of these communication tools. Security has reared its ugly head as a subject.
Yeah, exactly. So a lot of things are happening in the WebRTC space on that right now as well. I'll try to shed some light on this.
Well, great. Let's turn you over to the presentation. We'll pop that up and feel free to continue, Lorenzo. We're all ears.
Okay, thank you. Thank you, David, for the introduction. So yeah, this talk will basically cover some aspects of the new end-to-end encryption efforts that are happening in WebRTC, and I'll also touch Janus briefly because we have of course experimented with this a bit to see how it all works. And before we start, just a couple of words about me. So I got my PhD at the University of Naples in Italy a few years ago, and I'm one of the co-founders of a small company based in Naples as well that is called Miteco, that I co-founded with colleagues from the university. And I'm the main author of Janus, the WebRTC server that I did a workshop yesterday for. And there you can find some links to get in touch with me or to learn a bit more about my work and what I do for fun. And just to touch briefly on Miteco as well, it's a company that we co-founded about 10 years ago, and it was born as an academic spin-off at the university because we were all working at the university one way or the other. And we worked since the very beginning on real-time multimedia applications with a very strong perspective on standardization. And this talk will be, of course, involving standardization as well. And we do the usual things that you expect out of a small company like ours, so consulting services, commercial support, these kind of things. And we also try to provide streaming of live events also in these virtual event space that we are all living in right now, because we are actually provided remote participation support for the IETF meeting just last week. And we are all based in Naples, which is this beautiful city that you see over here. And by all means, as soon as people can travel again, come pay us a visit, because we'll probably fall in love with the city as much as we did. And so coming to the actual content of the presentation, first of all, you may be wondering, why are we talking about end-to-end encryption in WebRTC? Because many people actually believe, and rightly so, that WebRTC was conceived with end-to-end encryption very much in mind. And this is actually true when you think about two peers in communication. So if you think about these two people being browsers that talk to a web server, in this case, they eventually end up establishing a peer-to-peer channel, and this peer-to-peer channel is indeed end-to-end encrypted. So this server doesn't have access to anything, it just takes care of the signaling, media goes here, and it's actually end-to-end encrypted. But the things change when actually one of the two peers is an application, because if this application is a media server of sorts, it means that actually the end-to-end encryption ends at the media server. So each peer has an end-to-end encrypted session with their respective peers. So in this case, this user with the server, this user with the server. But in both cases, the server has access to the unencrypted media, which is something that sometimes you may want to overcome. And of course, this is not necessarily a bad thing. Actually, most of the times you do need the server to have access to unencrypted media. For instance, right now, FreeSwitch needs to have access to the media in order to do a composition, to do recordings and things like this. So all these require access to unencrypted media. But even when you are just relaying packets and not actually transcoding them, you may still need access to the packets somehow, so that they are not encrypted. Because to make a simple example, for simulcast, you may need to have access to some parts of the payload in order to figure out if a frame that you are receiving is a key frame, to make an example. And more importantly, you may need to have access to RTP headers and be able to edit them to change some fields here and there. So if you're wondering, can you get actually end-to-end encryption even when media goes through a server? The short answer is yes. The slightly longer answer is, of course, that it's not that easy, because otherwise we wouldn't be having this presentation. And before I move on, I want to point out to this presentation that Sergio Murillo from Cosmo actually made last month at ComCon, because I'll make a bird's view overview of most of the concepts that I'll talk about today, but I will not go very much in detail in some aspects of the end-to-end encryption. Sergio actually did, and he did a very in-depth analysis of the different approaches. And so I definitely encourage you to have a look at this presentation if you find my presentation interesting at the end of this talk. And so just to give you a bit of history, the IETF itself actually cared considerably about end-to-end encryption through a media server, which is why they actually founded a working group called PERC, Privacy Enhanced RTP Conferencing, exactly for this purpose. So the idea was to come up with a set of specifications, standard specifications, to allow participants to interact in a multimedia conference, but still enforce end-to-end encryption, even if the media was going through a server. I mean, the work is going on, and they also have some RFCs out there, but eventually the work was didn't exactly go out as planned, because it's not really popular among WebRTC developers, and so many have already expressed they've already stated that they will not implement this. And again, I will not go too much into the details about this, but basically the problem was that PERC was overly constraining in some of its specifications, mostly because it gave a lot of importance to how to avoid passing through untrusted components, which actually made the specification a bit too complex, and would basically mean that SFU implementations would have to change drastically to work, which would probably not work at all. And which is also why some people working in PERC, especially the Cosmo guys, actually came up with an alternative specification that tried to simplify all that, which was called PERC Lite, so a lighter approach to the PERC specification, which basically was a simplified approach that tried to envisage some form of double encryption. So we already know that WebRTC already does encryption via SRTP. But as we said, the problem is that the encryption stops at the media server. So the way that PERC Lite addresses this is by having some sort of double encryption. So instead of having just an SRTP packet like this, that then the server decodes and has access to everything unencrypted, you basically take this encrypted packet and then encrypt it again. So you basically do some sort of a double SRTP encryption. You have a hop by hop layer that basically the server has access to, and then end-to-end encryption that basically encrypts the media payload, which basically ends up with an RTP packet that still is a valid RTP packet as far as the server is concerned, but with the payload that is still encrypted, which means that it's a packet that the server can route and can do whatever it wants with. It just cannot access the payload, so it cannot access the audio frames and the video frames, let's say. Only if you have access to the decrypting information, and only participants do. Only in that case you have access to the media itself. This is really in a nutshell how it worked, and PERC Lite changed a bit the way that encryption also worked from the participants' perspective, because it basically allowed browsers to use JavaScript to configure some keying mechanisms, which was a strong difference from PERC itself. And we actually implemented this at the time as a proof of concept. So Cosmo implemented a fork of Chrome that implemented all of this stuff, and then we implemented the small parts that we needed to change to support this in Janus. And I mean small parts because actually the required changes in Janus were minimal mostly. You just needed to be aware that the packet was encrypted, and so that you had to take special care when routing packets and identifying some additional information. But actually playing with this, we actually came up also with some interesting things. So in this case, you can see a screenshot of me doing an encrypted conference using this approach. And actually, one interesting side effect implementing these things is that we found out that even recordings that in theory you would assume would be broken by end-to-end encryption could still work somehow using this mechanism. And this is actually tied to how we implement recordings in Janus. So if you attended the workshop yesterday, you may know that in Janus, recordings are done by just dumping the RTP packets exactly as we receive them to a custom file, a structured file. And so in this case, if we receive packets that are actually, that have the payload encrypted, we cannot, of course, process them. So we cannot extract, let's say, the video stream out of that. But what we can do is actually replay the same exact session later on, let's say. So we can just replay the same exact encrypted session back to a participant. And if the participant has access to the key to decrypt the content, then they will be able to watch the session as it was conceived originally, which is actually an interesting thing that has actually also some interesting implications for other kind of applications, because you could implement, let's say, even some form of pseudo DRM to do, let's say, streaming or broadcasting of encrypted content, and only people that are authorized to watch the media get access to the key, to make a simple example. Eventually, PERC Lite was abandoned, though, mostly because of it was not, let's say, strong enough in terms of the encryption properties as PERC needed. And recently, though, some other efforts came to the fore, which were called insertable streams, which are the main topic of this presentation. And insertable streams are basically just a new browser API that allow JavaScript applications to perform custom processing on WebRTC frames. And so by custom processing, I mean that you get access to a frame and then you can do whatever you want with it on the way out, and then you can do something with it on the way in. And of course, the main use case for that is indeed end-to-end encryption, because if the custom processing that you do is encrypting of the content, it means that if you get some encrypted content over the wire and without having to worry about the server getting access to the media. And an interesting change from both PERC and PERC Lite is that it doesn't work on individual packets as they did, but they work on encoded frames specifically, which actually has interesting properties because, first of all, it makes the whole insertable streams feature completely protocol agnostic, because right now we are using it for RTP, but WebRTC in the future will actually be based on QUIC, which means that it will be, the insertable streams will be usable exactly the same way, both on RTP and on QUIC, because in both cases you would work with complete frames rather than the packets as they are split in RTP. And this is important because most of the times when you have video packets, you actually have a single video frame split across 10, 20 RTP packets. So it's actually distributed. And so having something like insertable streams has some additional advantages, not only in terms of overhead, but also, again, in terms of making it more flexible for other use cases. And if you actually want to learn more about insertable streams in general, I actually wrote a blog post a few weeks ago, but the blog posts by Dr. Alex and Philip Anke that you can see over there are also very interesting because they go very much in detail about some of the standardization aspects as well. And if we want to have a look at insertable streams as how they insert themselves into the media workflow, it's actually quite easy. So if you imagine a typical WebRTC conversation, you can see that the browser typically captures media from a webcam. You get a media stream object. This encodes the video frames that the media stream is generating. Then you split this frame into multiple packets, as we said, especially if it's a video frame. You encrypt each of those packets. The packets go through the network, and the other end decrypts each packet, depacketizes the payload, which means if I got 10 packets that have the same timestamps, I know that they belong to the same video frame. I reconstruct the video frame out of that, I decode the image, and I render it on the screen on the other end. This is the typical workflow in any kind of RTC communication, really. And so insertable streams inject themselves into this workflow quite nicely because since they work on frames, they basically, on the way out, they insert themselves between the encoder and the packetizer. So the encoder spits out an encoded image ready to be sent. Before we packetize it, we can process it somehow, which can be a transform function that, for instance, encrypts this image, this encoded image. Then we enforce the RTP packetization on the encrypted stuff, and then we encrypt it via SRTP. So we still have some sort of a double encryption. And on the way out, we do the same thing. So eventually we depacketize the RTP packets, we get the whole encrypted frame, we pass it to insertable streams to be decoded, we get the original image, an unencrypted image ready to be decoded, and then we render it. So as you can see, in a nutshell, it's very easy to understand. There are a few challenges with this approach, though, as simple as it is. And first of all, it may be a bit problematic for SFUs to work with encrypted payloads sometimes. And for instance, I mentioned how SFUs may need, for instance, to have access to some information like, is this packet that I just received a keyframe, which we may need to have access to the unencrypted payload to do. And actually, there are some solutions to this. So one approach may be we don't encrypt the whole frame. So we might encrypt, for instance, all the frames except the first ones, because, and this is a very simple example, in VP8, the first bytes give you some information about the packets itself. So if you don't encrypt that part of the payload, you still SFUs still have access to what they need to get their job done, and the actual image is encrypted instead. But a better work for that is actually to use some ad hoc RTP extensions. So use some extensions that can be used for the job instead. And there are actually some specifications about to come up just for that. And besides, there's also the issue that encrypting the payload may actually confuse the RTP packetization and depacketization process, mostly because each video codec is actually packetized, has different rules for packetizations. And so for VP8, there are some rules, VP9, there are others, and H.264 even others. And so for some codecs, it may be problematic to work if they don't have access to the actual frame, and H.264 could be one of those. And so there are different solutions for this. You may leave some information available for these packetization purposes, but it's a bit of a hack. And let's say a better solution would be to use a global RTP packetization format for all codecs instead, which would not be dependent on the codec itself, and so would work with encrypted content as well. And there is a specification coming for that too. And if you're interested to learn how you can actually use this feature in browsers, you can use it right now in Chrome. So the most recent versions of Chrome have supported out of the box. And you can enable it by just passing some properties when you create a peer connection. And then you basically just need to configure the transform functions for the insertable streams. So as we said, we need one transform function on the way out. So basically all the media that we send that may need to be encrypted. And you can do that by configuring a transform function. You configure the function here, and basically this chunk that you see here would be the encoded image, the raw encoded image. You do your magic here, for instance, encrypted the packet, and then you enqueue the encrypted content, which means that then the transform function returns an encrypted image that the browser can actually send. And then to actually enforce this, you just work with the RTC senders in the WebRTC specification. So anytime that you add the new track, you get a sender, and you basically add this transform function on your sender to get this to work, which basically means that any packet that this sender generates will first go through the transform before it's actually sent on the wire. And same thing would happen on the receiver side as well. The format of the transform function is exactly the same. Of course, the transform function would be the inverse here. So it would get an encrypted frame, and it would need to spit out an actual image or audio frame that the decoder can work with. And basically, you also intercept the RTC receiver stuff from WebRTC instead. So anytime that you are made aware that there is a new track in the conversation, you can create your insertable stream here, and then you pipe your transform function here, so that any encrypted packet that comes on that track is decrypted properly before it is decoded. And we actually integrated this in Janus.js, our JavaScript library, recently, and it's in a pull request that we since merged, and we tried to make it simple enough to basically add these transforms so that the library does the heavy lifting. So all these things that you see here are actually not done by you, but done by the library instead. And then we implemented also some small demos. So for instance, we have a small end-to-end encryption echo test demo that allows you to verify how this is all working as expected. And I also played a bit with the video room, so to have encrypted conferences instead. And in this funny picture that you see over here, I am the bad guy, and I am unable to watch a session that has a different key than the one that I have instead, which basically proves that it is working as expected. But of course, I mean, insertable streams are one piece of the puzzle. And of course, the transform function is very important in this sense. And typically, you do not want to improvise the transform stuff very much. You want people that know what they are doing with cryptography to actually do this. And this is actually what happened with SFrame. So secure frames is actually a specification that the Cosmo people worked on for about a year before it was released recently. And it was both co-developed by Cosmo and Google, basically. And actually, Google is using this in Google Duo, has been using this for a while. And you can find some more information in that blog post over there and in that white paper that the Google paper presented. And recently, actually, it has also been brought to the ITF. So it was actually presented just last week at the virtual ITF meeting. And so you can see some more information in this draft here that basically provides all the specification of on the wire format. And there is also a dedicated mailing list where you can discuss all of this. And basically, SFrame tried to learn all the lessons from the previous end-to-end encryption attempts. So I mentioned PERC, I mentioned PERC Lite, and actually in PERC there were a couple of different approaches. And I mentioned Insertable Streams as a foundation as well. And basically, Secure Frames try to use these all these informations together. And first of all, since just exactly as Insertable Streams, it works on frames instead of packets, it greatly minimizes the overhead, because it means that all the crypto information is not replicated over multiple packets, which would add a lot of overhead, especially for video, but just on frames instead, which means that if you have a frame that covers 20 packets, you have a very minimal impact in terms of actual packet overhead. And besides, it tries to minimize the impact on servers and clients as well. So the changes that are needed on both client and server side are actually very tiny. So, and actually on the client side, you just need support for insertable streams, for instance. And on the server side, you just need to be aware that the packets may be encrypted. And most importantly, also the interaction with the key management system is done out of band and KMS agnostic. And for instance, there I mentioned Signal and MLS, mostly because Google Duo is actually using Signal for this. And MLS is a standardization work that is happening within the IETF right now exactly for this. So basically the two will basically work together out of the box when this is ready. And just to make you understand a bit from a high-level perspective how this all works, you can see that in a nutshell, it works very much as the insertable streams that we've seen before. So how you basically have the encoder generating an image, and then you have the transform function, and in this case is the SFrame encoder working before you actually packetize and send over the wire. And the difference is that this transform function here is, of course, guided by the keys that you set up when you actually establish the crypto context, which means that you have to exchange keys dynamically between all the participants in order to make sure that everything works as expected. And if you want to learn a bit more about this, there's actually the recording of the dispatch session where this was introduced at the IETF last time. And again, the presentation that Sergio made and that I introduced briefly at the beginning of this presentation, because it goes very much in detail also about how SFrame works from a crypto perspective as well. And Sergio actually also implemented an open source version of an open source library that implements this specification as well, which is available on this repository over here. And he described it very much in detail in a blog post and in the video that I was describing before. And this library implements everything except the key management system. So because again, SFrame is KMS agnostic, and so this is besides up to you anyway. And I actually helped Sergio test all this. So he implemented all the library, and he asked me to integrate this in Janus to verify that it was actually easy to use and basically whether or not this was actually easy enough to use, and whether there could be some things to make it actually easy to use. And so I documented all my efforts in that blog post that you see over here. And basically, I had to change just a few things in the library itself. So basically, I had to, first of all, I had to turn Janus.js into a module, because the SFrame library is a module, which required a bit of effort, but not that much. And then I basically exposed a way to allow an application to provide some of the information that SFrame requires. And then this information is used within the library itself to invoke the SFrame library. So in this case, you can see, for instance, if a key has been provided and SFrame has to be enabled, we create a new crypto content. We set all the keys that need to be used for the encoding part. And if we also know that we are going to receive media, we do the same thing on the receiving side. And then to actually enforce this, we do pretty much what I explained before. So again, SFrame provides you with the transform functions. You then have to hook them up to the WebRTC peer connection itself, which means that as soon as we create an outgoing track in WebRTC, we pass it to the SFrame library so that it can encrypt the content on the way out, and we do the same for packets on the way in instead. And eventually, I implemented all these as a proof of concept in both the Echo Test plugin that you can see here, but also in the Video Room plugin, where again as all WebRTC developers, I was talking to myself, but I was also simulating some malicious participants that basically didn't have access to the right key and credentials. And so the two duplicate Lorenzos that you see over there were actually making fun of him because he was not able to access the conversation. And this basically covers my my presentation. So again, this was a very high-level introduction to the to this new technology. And so I hope that this managed to sparkle your interest at least a bit. Again, I encourage you to watch Sergio's presentation if you want to have a very much in-depth analysis of all the implications and characteristics of end-to-end encryption from a lower level perspective. But I'm of course also open to questions if you have any for me right now.
That's great, Lorenzo. Thank you very much for that. I didn't notice any questions pop up that we need to immediately deal with. However, I would ask you, after you're released from the studio here, whether you would make your way to the broadcast cafe, and that's where people can come in and ask you questions. And of course, we're going to a break, so there'll be plenty of opportunity for that. But Lorenzo, I wanted to thank you for that presentation, but not only for the presentation, for your amazing contributions to the community in general. I mean, you know, creating an open source WebRTC server that you've given to the world is one amazing thing. And also the work you do with the IETF, some of which came out there. All of that is really positive, and we're very, very grateful for having you along here at cluecon Deconstructed.
Oh, thanks, Luis. It's very kind of you, and I really appreciate you, especially coming from you.
Now, before we move on to Abby, during the session, there was talk of Naples and what a wonderful place it is. And I was letting somebody know that I was very blessed to go to Naples last year for JanusCon. And it made me want to ask you the question, what can we expect from JanusCon in the future?
Yeah, actually, we are planning to host a new version of JanusCon, which will unfortunately not be in person, just as unfortunately cluecon couldn't be in person either. We haven't set out a date yet because we've been a bit busy with other things, but we plan to have a virtual edition of JanusCon somewhere in the fall, which may be October or November, we don't know yet. But we'll definitely keep everybody posted and make sure that people can submit a presentation as soon as possible.
That's very, very good news to hear. I'm sure a lot of the viewers here will be very pleased to hear that. Now, when JanusCon was going on, of course, it was co-located with VoIP on the beach. And while you can do a conference like this virtually, how can we do a VoIP on the beach virtually? I guess everybody will have to be at their own beach.
Yeah, first of all, I have to thank you again publicly because you helped MC that event and for the first time, and we really appreciated that. Yeah, but this is something that we also want to explore a bit. So there are a few things to figure out, but we really hope that we'll be able to make that possible again as well.
All right, well, that's good to hear. Thank you very much for your workshop yesterday and your presentation today, Lorenzo. We'll say bye-bye to you, and we'll have Abby back in the studio. And if you've got questions for Lorenzo, of course, you can find him in the broadcast cafe now. Now, we're going to go to a break, and we've got another hour of two more great speakers after that break, starting at 3:30 Central Time. But before that, Abby, I think you're itching to give something away.
Yes, you know I'm always excited to be giving out some free cluecon swag, so sorry to keep you guys from your break, but I've got a very exciting prize to give out right now. I am giving out a cluecon messenger bag. Very exciting. This is the first cluecon messenger bag in the history of cluecon that we're giving out, and our very, very lucky winner for that, let's play a little clippies in here to build the suspense. Let's see. Woo. 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 Our winner for this cluecon messenger bag is Ben Bradford. Ben Bradford, congratulations if you're watching right now. If you know him, hit him up and let him know that he just won a cluecon messenger bag. And if you're watching this right now thinking, well, how can I win some cluecon swag? I will tell you. All you have to do is spend some time in one of our cluecon Deconstructed conference rooms, hang out for a little bit, and you're going to be put right into our system automatically, and then you'll be eligible to win some prizes, which I think you're going to want to do. Because at the end of the day tomorrow, we're giving out this beauty. Ooh.
Very
an
nice.
exclusive ClueCon Deconstructed MacBook Pro. So make sure that you're hanging out with us. A great opportunity to do that is tonight at 4:30 p.m. Central until 6:30. The founders of FreeSwitch are going to be hanging out in the lounge. That's Anthony Minisali, Brian West, and Michael Jarris. So you can chit chat with them. Everyone's invited. And then tomorrow we've got the dangerous demos at 11 o'clock. Or 10 o'clock, sorry, 10 o'clock Central, which is going to be a lot of fun. And then that night we've got the Gigabit, which is going to be awesome. We're going to have karaoke, games. It's going to be a lot of fun. So make sure to participate in those to win some ClueCon swag. And if you're interested in purchasing any ClueCon swag, we do have a store open. The link is on our social media and our Slack channel at signalwire.community. And if you want to ask any of our speakers some follow-up questions, they're going to be hanging out in the broadcast cafe. So that's all I have. I can let you guys take a break. I'll be back at the top of our next speakers.
Well, thank you very much, Abby. And of course, anybody that is in any way watching any of ClueCon Deconstructed is already a winner. But we like to give stuff away as well. Now,
oh, how right you are, David.
Abby is right. We are going to a break, but don't go away. Make sure you come back at 3:30 Central, because we've got Norm Bradinger with a talk about Mosquito and the module he's done for that in FreeSwitch. Very exciting. And then we're going back to Italy. It's very international today, because we've had Nickolay from Russia. We've had Lorenzo. By the way, I meant to mention that Lorenzo, our friend Lorenzo Miniero, is one of 3 Lorenzos in VoIP. That's Lorenzo Miniero today. Tomorrow we've got Lorenzo Mangani. That's the second Lorenzo of VoIP, not in any particular order here. And then the third one, Lorenzo Military, is also involved, because he's the top man at Loway. And Loway, of course, are one of our sponsors in ClueCon Deconstructed. So we've collected the set, all 3 Lorenzos. But we're going back to
forget collecting all the Lorenzos.
we need a T-shirt with them or something like that, I think.
We may be able to cook something up.
But as I was saying before, I interrupted myself. After Norm Bradinger and his talk about the Mosquito module for messaging in FreeSwitch, we're going back to Italy to Giovanni Marazelli. So 2 great speakers to look forward to in the next hour. Thank you very much, Abby, and I think we can say bye-bye now.